Okay, good morning, good afternoon, everyone. Welcome to the NARUC Task Force on Natural Gas Resource Planning. Looks like we're up to 24 participants, and I see a variety of states on the list. So I guess we'll go ahead and get started. I'm Tammy Cordova. I'll be moderating our session today, which is on the coordination between the gas and electric sectors at the distribution level. We've got a couple of great speakers to talk about the topic. Oh, here's the agenda. Thank you, Ellen. And then we also are going to have a couple of task force members talk about their experiences. And we'll have questions and answers for all of that. And then at the very end, we have an update on what we're going to do next that Fitz Johnson, the chair of the task force, is going to go over with us. So packed agenda today. Looking forward to it. So the first speaker we've got this morning, or this afternoon, sorry, I'm on the West Coast, so it's morning, is Chris Giovanni. Sorry, Chris, if I'm stumbling over your last name. He is the Gas Strategy Program Manager for PG&E. And Chris, go ahead and take it away.
Awesome. Well, thank you, Tammy. So as Tammy mentioned, my name is Chris Giovanni, and I'm here to present PG&E's perspective on integrated gas and electric planning. So we can go to the next slide. So a little background on PG&E. So we're one of the largest combined gas and electric utilities in the U.S. We have a service area, roughly 70,000 square miles, serving Northern and Central California. We serve roughly 1 in 20 Americans with gas and/or electric service and have roughly 27,000 employees. We're also proud that we have more than 715,000 rooftop solar customers and more than 560,000 electric vehicles registered in our service territory. Next slide. So the state of California has very ambitious goals around reducing GHG emissions and has been aggressive in the policy and regulatory arenas to help achieve these targets. So this is very important context to note because it really affects how our gas and electric systems will change over time and therefore how we plan for those changes. So next slide. So in addition, PG&E published our climate strategy report last year. It outlines our 2030 climate goals, our goal to be net zero by 2040, which, by the way, is 5 years ahead of California's goal, and our goal to be climate and nature positive by 2050. So before I get into the next few slides, which gets into our planning efforts, it's very important to note what the state and our climate goals mean for the gas and electric systems. So we're planning for a future where we know our gas distribution system will shrink due to residential customer electrification. We're also planning for a future where our electric load increases, really kind of 3 factors there.
It looks like you got muted while you were speaking, Chris.
Sorry about that. Don't know how
No
that
worries.
happened. So I'll go back then. So we're planning for a future where our electric load increases really in 3 areas. The customer residential electrification that I just spoke of, growth in electric vehicles, and growth in data centers, especially with the energy needs of AI. So directionally, we have all of that in mind, but there's still uncertainties around the magnitude and the pace of those changes. So we also know that having an integrated planning for the gas and electric systems is critical, especially as a dual commodity utility, really so that we can ensure we're making the right planning and investment decisions, especially considering the changing dynamics of each system. So I'm going to give a spoiler alert. We're not there yet, but we do know that we need to integrate those planning processes, and we're starting to frame out what that will look like. So in the meantime, we've started making changes to how we plan each of those systems, and that's what I'm going to highlight for you now. So we can move to the next slide. So starting with the gas system, last year we stood up a new department called Gas Investments for the Future. So PG&E's gas strategy seeks to evolve the natural gas pipeline and storage system to be an affordable energy delivery platform consistent with our decarbonization goals. So with that, the GIFT department is tasked with shaping prudent investment in our natural gas system and reduce costs through asset retirements and down rates. So basically, how can we reduce costs while maintaining safety and reliability of the system? So we're taking a multi-pronged approach to how we manage the system. Again, with safety and reliability at the core, how can we reduce costs on the system? How can we plan for a future where the distribution system will shrink over time? And how can we ensure that we have the proper infrastructure to transport cleaner fuels to customers that will not be able to electrify? So a few of the proactive approaches we're taking, the first is identifying underutilized pipe in our system. So is there an opportunity to sell or retire pipe that is no longer serving customers? For example, we have an area in our system that has a cluster of gas producers that utilize pipe we own to bring their gas to market. However, we no longer have any customers on those lines. So we approached those gas producers to let them know that we're going to retire those lines. But before we retire them, we gave them an opportunity to buy the lines. Some of the producers are purchasing some of the lines, and for those lines that aren't sold, we are going to retire them. So by doing so, we've reduced risk on the system and have inherently reduced future maintenance costs. So that's one way of reducing costs. In the past, opportunities like this would only come up through project planning work in the area, whether it was safety work or compliance work. But now we have a team that is proactively and comprehensively looking through our system to identify these opportunities. So another area that we're looking at is downrating pipe. So this is another cost-saving approach, and it's really trying to identify local transmission pipe that can be downrated to distribution. So distribution pipe does not have the level of maintenance expense that transmission pipe does. So naturally, we'll save future expense dollars by doing these down rates if we can do so safely and not impact integrity of the system in that area. But the most important aspect of all this work is, the coordination across both our gas engineering and gas operation groups. We need to ensure that these cost-cutting and safety measures do not adversely impact work other teams are trying to do. For example, if we've identified a section of pipe to downrate, but we've got a dairy or a landfill close to that area that is developing a project to inject RNG into the system, we need to ensure that downrate will not negatively impact that project. Otherwise, we make the decision not to downrate. So again, the collaboration across different departments within gas is crucial. So next slide. So next, I want to talk about our Alternative Energy Program, which I'll refer to as AEP. The genesis of this program really started 5 years ago when we began taking a look at economics of gas line repairs. Someone had the idea to identify these projects where gas lines were serving only 1 to 2 customers and approaching those customers to find out if they would be interested in electrifying their home or business. So our goal was to avoid the expensive gas line repair that was no longer economical to operate, especially considering the investment needed to perform the safety work on the line. Typically, we will offer an incentive payment to the customer, helping to coordinate acquisition of electric appliances or any other upgrades that would be needed to complete the conversion to all electric. So a recent example of this is the electrification of 2 farms at the end of a gas line that was running under a freeway. Repairing that line would have cost $1.2 million and would have caused a 6-month freeway shutdown. So instead, we were able to electrify those customers at a cost of around $200,000 and retire that gas line. So over the last 5 years or so, we've done roughly 100 of these types of projects. And as part of the gift department, which I talked about on the previous slide, we're working to expand the alternate energy program. In our recent general rate case, we received approval for over $32 million per year for the alternative energy program. Essentially, the CPUC terminated our longstanding high pressure regulator program and allocated those funds to this AEP. So with that bigger pot of funds available and a team to execute on those projects, we're aiming to accelerate our efforts for these economically driven projects. One of the biggest hurdles we face, though, is the statutory obligation to serve. If a customer wants to keep gas service, we're obligated to make those gas investments and continue to serve customers natural gas. So I mentioned earlier that we have done roughly 100 of these types of projects, but that only represents a 40% success rate. We've had many more opportunities, but we're unable to execute on them because customers wanted to maintain their gas service. So next slide. So now I'm going to move into kind of at a high level on the electric side. So our collective electric system, as everyone is facing, right, a lot of accelerating multidimensional needs. You know, we've got wildfire, overloading, asset health, reliability, equity, climate risk. So we need to address all of those in order to deliver for our customers. So as a result, we really need to evolve our grid planning to efficiently address all of these complex needs. So along those lines, we've established an integrated grid planning process. This is a data-driven approach to optimize our plan around strategic objectives. So strategic objectives around the distribution system include wildfire risk, capacity, asset health, and reliability. And strategic objectives on the transmission side are capacity, asset health in high wildfire consequence areas. So our IGP builds on our current approach to planning to maximize impact on our system in various ways, such as our ability to solve multiple needs on the system at the same time by moving away from addressing needs in silos. You can actually go back to the previous slide. I'm still moving a little bit there. There you go. So, you know, by really trying to address multiple needs at the same time, it's resulting in risk-informed capital plans that integrate other objectives, which helps us to deliver our multifaceted goals for the system. Secondly, to transparently track the impact by clearly understanding how work on the system will impact overall system needs, which will result in making informed decisions about trade-offs and prioritizing work that will deliver on those shared objectives. Third, building stable plans by creating long-term visibility into what will be done and when it will be done. This results in multi-year capital plans that enable advanced resource and operational planning so that we can better respond to our customer needs. And then finally, efficiently using resources by maximizing the impact of every dollar spent on the system, resulting in maximizing efficiency, considering a range of possible solutions, addressing multiple needs, and really doing the best that we can to bundle work at the circuit and substation level. So next slide. So a couple of ways that we're approaching our grid planning include utilizing IGP for gas to allow for risk-based assessment and identification of opportunities to retire assets in areas of high electrification. One example being areas where we can electrify instead of replacing out-of-lay pipe. Another approach is figuring out how we can generate energy on site or near, as opposed to just building wires to bring energy to high load need areas. In addition, having a better long-term planning approach enhances our monitoring of risk factors. Really knowing a project is 5 years out helps provide stability in planning instead of our old way of year-by-year planning, which created a lot of uncertainty and additional costs, not knowing if a project was going to get done that year or not. And then finally, I mentioned earlier, you know, capacity is an issue, especially with EV load forecasts, building electrification, growth in data centers. This IGP framework helps better plan for those capacity needs. Those needs really mean we could be tripling the amount of energy we deliver in the next 2 decades. And it really is a super amazing opportunity to innovate. So our IGP capacity view comes from the strategy and planning teams and how can we get ahead of that. So we're also starting to have a lot of communications and conversations with our customers, discussions with generation partners, with really the goal of strategically locating generation, you know, close to those high load need areas so that we can, again, avoid building out long lines of wires wherever possible. So to finish where I started, IGP process needs to include an integrated gas and electric planning process. We're starting to lay the framework for what that integration looks like. And really planning those systems together is going to be critical for us to establish our carbon neutral energy delivery system of the future, which is going to take both the gas and electric systems to deliver not only clean, electrons, but also clean fuels to our customers. So that is all I have. Thank you.
Great. Thank you so much, Chris. That was really interesting, and I do have some questions, but I'm going to hold them and let Gerard, did I get that right?
Close enough, yes.
Do his presentation, and then we'll allow all the commissioners to ask all of their questions after both. So our next speaker is Gerard Walker. I'm really sorry, I'm not doing a great job with the names, but he is the manager of advanced forecasting and modeling with Eversource Energy. So go ahead and take it away. How about I do this, Mr. Walker, please?
Thank you, Tammy. And thanks for the quick introduction. So as mentioned, my name is Gerhard Walker. I work at Eversource Energy and lead the advanced forecasting and modeling team, part of which is the integrated energy planning function for Eversource. Next slide, please. So a quick overview over the company. Eversource services 3 states in New England. We cover Connecticut, Massachusetts, and New Hampshire, with varying territories of gas and electric. And especially in our area, we do have certain territories where we own gas, where we own electric, and where we own both, which makes especially integrated energy planning a very interesting proposition as we have cross-utility coordination efforts. Overall, we have about 4.5 million customers and more than 600 communities and close to 10,000 employees with Eversource. Next slide, please. So for today, for the 15 minutes, I wanted to bring a couple of topics, and I'll do my best to stick with those 15 minutes. There are 2 major regulatory initiatives that have been driven in Massachusetts with the DPU, with the vision in mind of achieving the state's clean energy objectives. And one is the Electric Sector Modernization Plan, and the other is the Order 2080B for the future of gas. Then high level, and I'm going to cut this short after the presentation. Chris has already given a little bit on the concepts of integrated energy planning, not to duplicate too much of what's being said, and how we are targeting it at Eversource. Specifically, what are we implementing at Eversource? And then a couple of key early lessons as we're setting this up, as we're moving through this process and trying to define how and what is done. What have we learned? What have we found? That's kind of the idea for today. Let's get started. Next slide, please. So the Electric Sector Modernization Plan was called into action in 2022 when Massachusetts passed House Bill 5060, which pushed the utilities to develop a comprehensive plan that looks out not just 10 years or 15 years in the planning horizon, but all the way out to 2050, look at the system, what is needed on the system, and come up with proactive planning solutions that would help achieve the state's decarbonization objectives. So those plans were filed in January of this year with the DPU. We're awaiting decisions probably by end of the summer from the department on those plans. But at a high level, speaking for Eversource, what we found in our analysis that if we are transitioning away from fossil fuels, both in the transportation and heating sectors, we're looking system-wide at an increase of our peak of about 250%. So an increase by 150% of our current loads, from roughly about 7 gigawatts all the way to 15 gigawatts in the future. Most of this driven by heating, and the second largest component being electric vehicles. We also have very ambitious solar targets in the state, currently looking at about 23 gigawatts to be deployed as part of this decarbonization roadmap. So the plan also looks at how these solar installs can be integrated into the system. And I think, I hope I'm not misrepresenting this, but as first in the nation, together with the Massachusetts Department of Utilities and the solar developer stakeholders, we've been given an order by the department to upgrade the system in so-called CIP, Capital Infrastructure Project areas, to integrate solar at a large scale, transitioning away from a purely cost causation principle for large-scale solar integration. So this is the electric sector modernization plan that looks at the holistic system planning for the electric side. Next slide, please. So looking at from the gas side, end of last year, the department issued the Order 2080B, the future of gas, where the department took a visionary step towards understanding how we integrate both gas and electric planning. Now, there are a lot of components to this order, but for the purposes of today, I'm going to focus on a couple of key items that really drive forward what we're looking at in terms of integrated energy planning. So one item is the mandate to develop electrification pilots, pilot areas where we look at targeted electrification to offset capital investments into the gas system, as well as developing non-pipeline alternatives, or NPAs, as options to gas planning, and requiring the utilities to coordinate gas and electric investments. So those are the three key items that we'll focus on for today in terms of what's driving Eversource to really take a closer look at how we conduct integrated energy planning. In terms of timelines, as I mentioned, the first major filing on this from our end is due April 1st, 2025, and then there's a 5-year turnus after that. Next slide, please. So conceptually, at a very high level, and my colleague from PG&E had a lot of good details on this, so I'll try to shorten my speech on this a bit. What we're looking at for integrated energy planning is understanding where capital investments into the gas system can be addressed through non-pipeline alternatives, or in almost all cases, electrified solutions. Now, this could be network geothermal, this can be ground source geothermal, air source geothermal. We can talk about direct electric and all other opportunities here to offset that need. Vice versa, on the electric side, we're looking at the same concepts, and the companies already had a fully established non-wires alternative process of how investments into the electric system, which will then be driven by those NPA analyses, can potentially be offset by non-wires investments, be that storage, solar, energy efficiency programs, demand response, you name it. In the middle of this sits this integrated energy planning process, where, and I'll get to this in a little bit more detail on the next slide, the companies established a group of both gas and electric planning engineers that work together in one team, using the same tools to look at iteratively scaling these projects, be that for non-pipeline alternative or for the targeted electrification pilots, to understand how large of an area can we target, what segments of the gas system could potentially be taken out of the capital plan, how can we electrify, what is the cost upgrades to the electric system, and most importantly, what are the upgrades to the behind the meter investments for the customers? If we electrify customers in a targeted fashion, what has to happen behind the meter to the customer to make that possible, and how are those costs allocated? So this new group, if we go to the next slide, is brand new within Eversource, was established as part of this order being issued. We have essentially 5 functions in this team. A data solutions team, and I'll talk to this a bit on the early lessons learned, to support this effort with customized solutions that we develop in-house, software solutions that we develop in-house that allow this planning of both joint gas and electric efforts to press. System modeling team, this is a dedicated team with the sole purpose of maintaining and operating our electric and also in the future gas models to make sure they are up to data standards and accurately reflect everything that's on the system. Our team is the advanced forecasting team. That team's been in existence for a while. That has also been the team that has driven the electric sector modernization plan that we have talked about earlier, and the regulatory support team. But together, those 5 components I can't count anymore, basically drive forward this integrated planning and support it. We need forecasting to understand what the next 10 years look like. What do electric vehicles look like in our targeted areas? What is the natural adoption of this? Who has a high propensity of buying heat pumps? Who doesn't? So to Chris's point earlier, like where are the customers susceptible for going along with an electrification project, and where are they less likely? In addition to that, we have a key contributing team. So those aren't part of the same functions, but they're very closely integrated into the work we do. That's distribution engineering, both on the gas and electric side. Energy efficiency is a key component to this team. In Massachusetts, we have well-renowned energy efficiency teams with very aggressive targets driving forward clean technologies in the state. And their input and their help in defining these areas and supporting the transition is key to this effort. Rates is another big topic as we're going through how we pay for these efforts. We might save money on one side, we have to spend more money on another side. How is that reflected in rates, specifically in an equitable fashion, that we don't end up overburdening certain portions of the population? So this is how Eversource is currently implementing this internally from an organizational standpoint. Next slide, please. So while I didn't want to go into too many technical details, I did have 2 slides on just a little bit of detail on how we're thinking about this as we're looking at potential areas. So high level, we have millions of pipes on the gas system in our territory. And the company is developing a prioritization matrix based on the contents of the order 2080, based on our GSEP pipe segment, so the leak-prone pipes in the system, and figuring out where the ideal targets are. This will give us a ranking prioritization of pipes and projects that then go into this integrated energy planning process, where we iteratively review, scale up or scale down the project size to understand what the impacts on the electric system are, what the impacts on the gas system are. We can't remove every pipe segment. There are hydraulic considerations to be had. And that is what this group specifically focuses on. At the end of this, we'll have a handful, call it 10 projects that are high priority targets for us, at which point we are going to reach out to the communities. Now, Chris, I have to say, it has me thinking about this positively, that you have a 40% success rate in finding and willing people to participate in this, because that's our fear here, that even if we find 10 good areas, that getting people convinced on how to do that transition with us, that there's always going to be some holdout at the end. So that's where we're taking those projects and then engaging with community relations. Our community relations already early on engaged in the prioritization matrix as we're looking at these communities to make sure, again, that we're targeting communities where this fits well. Next slide, please. So early lessons learned, and this is the last detailed technical slide. The first thing that we noticed, we started looking at this about 6 to 9 months ago on the technical side, and we found that there are very limited amount of actual tools in the market that would allow us to do this. Now, we're in the fortunate situation at Eversource that both our gas and electric planning teams use the same planning tools. They're from the same vendor, so this gives us a joint data model, at least at a minimum. But after reviewing several vendors and talking to external companies, we've started moving forward with an in-house development of a tool that allows us to take all of our gas and electric models and merge them into a singular model that overlays the gas and electric infrastructure. So practically speaking, what we can do is we can take a look at a certain pipe segment and say, okay, X amount of customers here, map them directly to our electric circuits, understand what the impact is if we electrify those on the electric system, and automatically run an analysis on the electric system of what this looks like. So we're doing that as in-house development. And if you remember the earlier slide where we talked about the key functions in the team, that is our engineer data solutions team that focuses on developing these capabilities. That's the first thing we've noticed, and like I said, we're in a fortunate situation that we do have a joint data model because we're using the same tools. This will get more interesting as we start coordinating with the other EDCs and LDCs in our territory, because on the top right, it's hard to read, but red is electric only us, blue is gas and electric us, and green is gas only Eversource. So we have a lot of overlap with our joining companies, which use different solutions. So this will get more complicated as this progresses. Next slide, please. Yeah, and then at the end, I just wanted to a couple of topics where discussions are still happening. Very interesting questions that need answers. One of them key point is reliability on the system is going to be paramount in all of this discussion. As we electrify, we cannot put in jeopardy the gas supply or specifically the electric supply as we add more and more load to it. So having that joint planning function that can look at both the gas and electric side jointly at the same time in the same team is crucial to a success here. Data sharing is, especially again for us, a topic that we are thinking about because it is not just between our own companies, but with other companies in the same state where we need to be able to share data. If we have a certain gas territory where there might be a project and another utility holds the electric side to that, that is an interesting discussion to be had, how that can be done in accordance with all the governing rules and regulations on, especially if we're looking at personal identifiable data or critical infrastructure information. And then, of course, and again, I'd love to hear the discussion on this. Our topics around, what are the priorities? Is it GHG emissions reduction or gas investments? And I saw, Chris, for example, on your slide that you're offering also alternative fuel supplies on this. We're more focused on the electrification side. And so this is an electrification targeted approach. And then cost allocation is another key topic, as I mentioned, where there are still questions open that need to be answered on how these transitions are paid for. And I think with that, I've already exhausted the 15 minutes. I don't want to go too much over and leave some time for the discussion. So thank you for the attention, and looking forward to the questions.
Great. Thank you so much, Gerhard. So now we can turn to questions for both of our speakers, and